What perhaps transformed the landscape of artificial intelligence was the concept of transformers, which helps the models to better understand contextual information. The transformer architecture, which was proposed in the 2017 seminal paper Attention is All You Need, allows the models to assess the importance of each word in a sequence. In other words, it assesses which word deserves more attention in each context. It identifies the distance between words that influence each other. This attention mechanism processes relevant input words and masks other information in words that are not very relevant. Owing to the parallel processing, transformers have this attention mechanism which lets them learn from complex relationships between words and, by extension, ideas in natural languages. Transformer architecture includes an encoder and a decoder unit. The encoder unit has 6 layers, each with 2 sublayers. The first sublayer is a multi-head mechanism which generates multiple parallel outputs. The second sublayer is a feed-forward network. In this sublayer, the input data, for example, a sequence of some words, enters 6 layers of encoders where each layer uses its own weight and bias parameters, for example, the weight or importance given to each word in a sequence. The encoder unit takes all the words in a sequence without paying attention to their order or position in the sequence. Instead, it encodes their positions in a vector for itself so that later on it can retrieve their positions. The decoder unit has 6 layers with functions, each with 3 sublayers. The first sublayer receives the output generated from the encoder, then provides positional information about the words, and applies a self-attention mechanism where only the previous words in a sequence up to a point are considered. The second sublayer receives both the output from the encoder unit as well as previous decoder layers. This allows the system to pay attention to every word, both regarding and regardless of their positions in a sentence. In the third sublayer, another feed-forward network is applied to find the final predicted word based on the information from the previous steps. Therefore, the decoder unit converts the encodings back to probabilities, which are in turn used to select the output words or the next word in the sequence. Since the transformer neural networks put the importance of any token from the input in the context of other input tokens, they are great options not only for natural language processing, but also for the processing of any sequences of data, such as genomic sequence and time series data.